So the objectives for today are to learn about and discuss key concepts from the study of complex system behaviors and consider how these insights from the study of complexity and system behaviors may inform thinking about the TCLP transformational change concepts. I think several of you probably know Johnny. He's been an active member of the CMM interest group and is an expert in organizational psychology with extensive experience in program evaluation. And his focus has really, in recent years, been on applying complexity and concepts and lessons and research from the field of complexity studies to apply to the evaluation field. Johnny is an active evaluator and owner of 4.669 Evaluation and Planning. And with that, I just want to thank you, Johnny, and welcome you to present today. We're really excited for this.
If we're ever able to travel again, I will buy a drink for anybody who can figure out why I named my company the way I did. Cool. Okay, so here's what I want to do in this presentation. The first thing I want to do is just give you a glimpse of how complexity can help our thinking about outcomes, about our processes for getting to outcomes, and how you evaluate interventions that will affect those outcomes. And the word glimpse is really the critical word there, because I can't do anything more than give you a very brief view of the world. If you look at that picture on the bottom, I don't expect you to look at the whole thing. You can go and look at the URL if you want. That's basically a visual overview of sort of the intellectual history of complexity. And I only put it up there because it's a busy slide, and I wanted to convey the fact that there's a lot going on. And so you can see how, if the world is even close to that particular picture, why this notion of like giving you a glimpse is really all I can do in half an hour. And so what I'm going to do is not try to cover all the material even that I have. I'd rather explain it well than try to get through it all. I guess you guys are going to tell me whether I succeed or not. But as I said, you need to think of complexity as a big interdisciplinary field, and what we're really doing is taking little peeks at it here. Okay, what I'm going to do, we're going to cut to the chase. I'm going to give you my last slide first, and then I'm going to come back to it, because I want to sort of give you the picture of how things, of the conclusions that I want to reach. And that way, if I don't get all the way, at least we're doing okay here. I tend to think in terms of complexity as relating to models. And I've got these pictures up here. If you look at the model on top, right, these are all things I made up, but that's sort of not an unusual kind of model for people in our business to think about. God knows I've done plenty of them. I'm not against them either. But the fact is that it has some assumptions in there. First of all, it says we can specify all the relationships, right? We know all the connections. There's only one path really, or at least definable paths from action to outcome, right? You can see the arrows, you know how you get there. And it says we know all the outcomes, we know the relationships among those outcomes, right? Outcome 1 has a relationship with outcome 2, outcome 3 is sitting out there. And I think we would all believe that essentially for the kind of evaluation we do, this is silly, which it is. On the other hand, I bet we've all used models like that, and sometimes to good advantage. The second set of models in the gray back box are much more complexity oriented. They're complexity oriented in the following sense. You have multiple paths from whatever your intervention is to the outcome. It says that we can't specify the outcomes exactly. We can only specify some outcome cloud. And that's much more of a complexity-based view, and I'm going to explain why that's true. The problem is, you'll notice it says scenario 2, scenario 3, scenario N. The difficulty here is that there are multiple paths that one can take to get to this outcome cloud. And if we're going to do an evaluation based on anything related to the gray box, we're going to have to pick one of these. We're going to have to say, well, we're going to evaluate relative to scenario 3, or we're going to evaluate relative to scenario 12, whatever it happens to be. But we have to pick one. And that implies that the others don't matter. The most complexity-related relevant model is really the simplest one in the bunch, which basically says we have our scenario. It affects a bunch of stuff. We know that this bunch of stuff is connected somehow, but we don't know exactly how. But we know that if we do enough of that stuff, something is going to happen. Now, in some sense, that's that's sort of a common sense view of the world. But the truth of the matter is that there are very good complexity-related reasons for for the yellow model. And it has implications for methodology and for how we conceptualize programs. So having said all that, what I'm now going to do is go through some of the principles of complexity to give you a sense of why this scenario at the bottom, as simple as it is, actually makes sense in terms of how we know how the world works. So that's the final scenario, right? We can look at things in retrospect, but if we want to know how to get from scenario A to B, instead of taking a backward look, do a bunch of stuff and something's going to happen. And now let's find out why, from the point of view of complexity science, that's true. Yeah, I'm not going to dwell on this. Let me just say that I'm a great believer in the Humpty Dumpty theory of semantics, which is that a word means anything that I want it to mean, or as Justice Potter Stewart said in a famous case in the US about pornography, I don't know what it is, but I know it when I see it. But in both of these cases, words are slippery. They can mean lots of different things. And that's why I don't like talking about complex systems, because I don't know really what they are. And I can give you a definition, but someone would give you a different definition, and one will be okay for one reason, one will be okay for a different reason, but we get into a big argument about it. And the other problem is in terms of doing evaluation. When I do evaluation, I think about models, I think about metrics, I think about methodologies. If you tell me something is a complex system, I don't know what to do about that. But if you tell me that there are behaviors of complex systems, I know what those are, and that can affect what my models are, what my metrics are, what my methodologies are. So I tend to try not to talk about complex systems if I can help it. So there are an awful lot of, if you think about that picture I showed you in terms of the intellectual history of complexity, there's an awful lot going on here. And so the real question is, what is it in this domain of multidimensional domain of complexity that's useful for doing evaluation? And the best I can do is give you my answer. These are the ways I tend to think about it. If other people want to think about it differently, more power to them. My thought of it is this: no matter what domain of complexity you look at, no matter what theories you have, and no matter what intellectual background you have, the constructs in complexity, in one way or another, deal in some combination with pattern and with predictability. And when I say predictability, that really also means explanation. And there's a lot of interesting philosophy about the difference between predictability and explanation, but we're going to leave that alone for the moment. We have predictability and pattern and how things change. By how things change, I mean the dynamics of change. So one question is, what's the pattern? What can I predict? The other question is, how do we get there? Right. So that's issue number 3. And as far as I'm concerned, and this is personal, if other people like different concepts, I'm good with that too. But there are basically, how many do I have? Is it 6? 1, 2, 3. There are 6 concepts in complexity that I find particularly useful in understanding how to do evaluation. And by the way, if it's useful for doing evaluation, it's useful for program planning as well. In any case, what I will do later on towards the end is come back and explain all 6 of these if we have time to do it. But the ones in yellow, this notion of attractors and sensitive dependence, are the ones that I want to pick to give you an example of how thinking about concepts and complexity can help us understand why these various models that I showed you originally are or are not, do or do not capture what we know in complexity science. So I'll deal with attractors and sensitive dependence. All this other stuff, hopefully you're curious about, and if we have time, I'll come back to it. But if I start lecturing on all that stuff, we'll never get to the end. So let's take a look at the next slide. The first thing I'm going to do is talk about what an attractor-informed perspective on transformation is. In other words, if you think about this notion of attractors and complexity and take that seriously, what does that tell you about thinking about transformation? So what does an attractor mean? Well, colloquially, it's the new normal. And that's actually not a bad way of looking at it. But complexity nerds have a much more complex, elaborate, I should say, view of what this all means. And you can see the references on the bottom there. But basically what it has to do with is this notion of coming back to some central place. Dynamical systems, what you really want to do is read the red values toward which a system tends to evolve for a wide variety of starting conditions. Drop something into some system, watch what happens to it over time. If it tends to evolve towards some particular value or some particular set of values, that's the attractor. Think about a pendulum, you can think about a watershed, you can think about orbits of a planet, you can think about kids on a playground, actually, very strong attractor. You can think about these in terms of social attractors, not just hard physics. And what you have, if you look at the red, is a subset of states of the social system that it can take, behaviors toward which it will naturally gravitate. So we have this idea that if you let things alone to do what they want, they will often, or at least sometimes, go to a particular place. This to me has real implications for evaluation, right? The technical definition leads to questions about the topography, right? And one of the things I like to think about is, if you think in terms of complexity, how does that let you think differently than you would normally? Because a lot of people are going to look at this complexity stuff and say, real interesting, I would have done that anyway. And my answer to that is, that's fine. If you would have done it anyway, that's great. What I believe is that thinking in terms of these complexity concepts actually makes people, or at least me, think differently about things. So here's an example. If you think about attractors, the range of values an outcome can take. You can think of the range of values as having a shape. You can think of it as having a set of boundaries. You can think of it as having parts to it that are very deep, meaning if you have that particular value, it's going to be very hard to change it. You can think of the attractors being very shallow, meaning that if you push it just a little bit, maybe you're going to push it out of that basin of attraction. But when I think of attractors, I tend to think of shapes and depth and ranges in ways I don't think about when I think about normal outcomes. The effort needed to affect change, right? And that you can think about that in terms of sustainability or in terms of resistance to change. But in either case, I mean, I'm sure you guys have the same experience I do. You can take a program, you can whack it over the head with data forever, it never changes. That's an example of an attractor, a very strong one. And so if you think about attractors, you think about their size, and you think about their depth, you can get some sense of when might it be easy to affect change, when might it not, and what is the landscape of change that you need to implement effective programs. Issues of directionality, right? Is movement in one direction easier or harder than another direction? Could actually say a lot about that, but I'm not going to right now. And then commonalities with other phenomena. This is one of the things I find most useful. Imagine you have two programs that are unrelated to each other. I used to do a lot of evaluation of regulatory programs across different federal agencies. And the fact is that when I began to think about the attractors for the outcomes of the safety programs that I was dealing with, I realized that even though the settings were totally different, the shape of the attractor was very similar. And that really means that there might be hidden similarities, not obvious similarities across seemingly different programs. And why might that be? That might be because when you look at the attractors for the outcomes, they seem to be the same in terms of their boundary, in terms of their shape, in terms of their depth. Now, it doesn't mean that they are the same, by the way, but it certainly raises all kinds of questions that at least I would not have thought of before. So that, to me, is this notion of an attractor and why it brings up questions about how programs behave and how you compare programs that at least I would have been unlikely to think about before I knew about attractors. Now let's look at the second concept, which is on the next slide. Let's talk about sensitive dependence. What is sensitive dependence? Well, there's my definition. I got it from the Santa Fe Institute, which is a great website, by the way. It refers to the role of the starting configuration of the system that it plays in determining subsequent states of the system. This is the famous butterfly effect, right? The butterfly flaps its wings somewhere and it causes in South America, it causes a hurricane in the Gulf of Mexico, that kind of thing. Let me disabuse you of that notion, right? It doesn't have to imply instability and unpredictability. In my business, as I said, the problem is that the world is too stable, not that it's too unstable. You hit things over the head with the data all the time, it never changes. So there's my band the butterfly symbol, because people tend to think in terms of sense of dependence as the world is very unstable, little things happen, you get cataclysmic changes later on, and that is not a good way to think about it. But what it does do is imply unpredictable paths through a system. And if you think about the models I showed you at the very beginning and that last model where I said we can't predict what it's going to be, that is a function of sensitive dependence, because it means that you can make a change in a system. That change will rattle around throughout the elements. It may in fact be because of the attractor behavior that you know more or less where it's going to end up, but you don't know how you're going to get there. Right? I can predict where I'll end up, but I can't predict exactly how, because the path might change through each passageway. What I can do is determine the change in retrospect. Right? It's like accident investigation. If I said, here's what happened, can I figure out how I got there? Assuming that you have the data and you can do the analysis, you can certainly do that. The question is whether you can assume that the next time you take a path through, that is the path that is going to lead you from your intervention to your outcomes. That you cannot do. And that was the problem with the gray boxes that I showed you in that first picture. And we're going to come back to it, which is, which path are you going to take? Right? You got to pick one, but that might not be the one that happens next time. So if you simply say, I'm going to look at everything that happens, I'm not going to predict, I'm not going to guess in advance what the relationships are going to be, then that puts you in a position to accept the fact that because of sensitive dependence, you don't know when you enter the system what the path is you're going to travel through. But it might be predictable. Right? It might be that, that's why I have my band butterfly sign here, because it doesn't necessarily mean unpredictability. So now hopefully I've got you thinking both about the issue of the concept of sensitive dependence and the concept of an attractor. So let's see if we can put it all together on the next slide here. What might an attractor sensitive dependence definition of green transformation looks like? So now what I'm going to try to do is to take these concepts of complexity science, attractors, and sensitive dependence, and apply this to the question of transformation. So here's the example I came up with. How do you define transformation? Well, in this particular case, we know it's happened when it's a particular geographical location. About 80% of the energy use comes from green sources. It's remained that way for about 5 years. If you don't like that definition, pick other parameters, but this one works for me for this example. So what do we have? We have time. We picked 5 years. Why did I do that? I did that because I want to see if the attractor is stable. Remember I talked about the idea that some attractors can be stable and some can be not stable. Right? And so I want to make sure that it's not ephemeral. Is 5 years enough? Maybe I need 10 years, maybe I need 1 year. That's a conversation that can be had. But the idea that you need some sense of the stability of the change to know that the new normal really is normal is an attractor-based kind of a concept. Imprecision, right? We acknowledge a range of concepts for the boundaries of the attractor, right? We said about 80% because it's not so much a question of a mean and a standard deviation, although you could think of it in those terms. But it really has to do with the idea that here's a domain that you're not going to move out of. And so that's why I like to think of this idea of about 80%, not simply in terms of a mean, but in terms of some value that rattles around within a space. Measurement, well, that's not a formal aspect of my definition, but I'm in favor of measuring everything. Level of energy use, why 80%? Because it's really different, right? It really is a new normal. It's the default choice, right? It can only come about if there's a profound change in energy sources and their supporting constituents. I like to think of an attractor as the low energy state. In other words, leave it alone, let it do what it wants, that's where it's going to go. And 80% is an example where there needs to be enough change that if you just let it alone, that's where it's going to end up. If someone said, well, it should really be 30%, it should really be 90%, again, you can have that conversation, but the idea that it has to be big enough to make a difference in terms of, is it really a new normal? That's an attractor question. Geopolitical boundaries, right, in state, region X, whatever it happens to be. Why did I pick that? Well, one of the reasons, we don't know what all the elements are, right? If you think about that model that I have, that yellow model, right? Why do we have a new normal? Well, it's some combination of the availability of equipment and having the expertise to maintain and install it, and what the political consensus is, and peer pressure, and culture, and regulation, right? You go on and on and on as to what these individual variables are. You can't measure them all, and you don't know the relationships exactly among them anyway. But if the geographical boundary is big enough, my idea was that that's kind of a proxy for all this other stuff existing. If you don't like that idea, we can talk about something else. What I was thinking is, you got all these variables, you don't know exactly how they're interacting with each other, you need some proxy. I figured geographical boundaries would be good enough. What's the appropriate boundary? Well, you know, someone said a small town somewhere, and someone else said it's got to be an entire country. I don't know the real answer to that, but the idea of some real geographical boundary matters. So now we have this question, how do we build a causal model, right? How would complexity handle this kind of a definition of transformation if we believe what we believe about sensitive dependence and about attractor states? And we get back to this original picture of mine, which I'll talk about now in a little bit more detail. And then if we have time, I can either ask questions, or I can double back and talk about some of those other concepts in complexity that I did not talk about. That top picture, to me, that is an expression of hubris, frankly. It says, we know an awful lot about the world. And when I step back, I give that the sniff test, and I said, if I had to be honest with myself, I can't believe I know enough about the world to write a model like that. But I'm sure we have all seen many models like that. But if you take that step back and say, do I really think I know enough about the world to draw a model like that? I think you'd have to admit that the answer is no. But even if you did know enough about the world, what it really says is that everything is deterministic. And I don't believe that's true. And if you think about what I said about sensitive dependence and attractor states, you can see how the science of complexity gives us reasons to believe that it's not true. It's not simply our common sense that it's not true. If you look at these models in the middle, those begin to acknowledge complexity, because what it says is there are many different models that might get to the outcomes that we want. And we don't know which ones there are, and we don't know if n is infinite or n is not, but it's a big number. And so this begins to say there are lots of ways we can get from our scenario, maybe I should call that our intervention, to the outcomes. And it acknowledges the fact that we can't say exactly what the outcomes are, how they relate to each other. So we are at least beginning to acknowledge some kind of an attractor state, right? That here is a region within which these kinds of things are going to happen in some ways that we can't tell. The difficulty with the gray boxes is that you have to pick one. And when I say pick one, if you remember, I went back to my view of evaluation is models, metrics, and methodology. So if I thought that scenario 3 was really what's going on, I would need a methodology to measure that. I would want a methodology not only that measured, 1, 2, 3 up through 9, but it posits relationships. I would want to collect data to see if those relationships held. The difficulty is that the next time I go through the system, because of sensitive dependence, there might be some other connection. So that is the reason why I see these intermediate outcomes as beginning to recognize attractor states and sensitive dependence. But the one that recognizes it most is scenario A, which basically says, do a lot of stuff here and a lot of stuff there is going to happen. Now, I don't mean to imply that you can't assess the relationships among these things. And I think you should. What I've advanced. What's true in scenarios 2 and 3 in the gray box is a methodology that says, I in the middle one, there's a connection between 9 and 7 and a feedback loop between 7 and 9. And if you believe that, you would say, I know in advance that I need to have a methodology and I need to have measures that will let me see if 9 leads to 7, and if 7 happens, whether there's a feedback loop between 7 to 9, and if 7 happens, if there's a relationship between 7 and 2, right? And you would have to put into place a methodology in advance to measure all that stuff. Whereas if you look at what's happening down below, it's really much more of a, I need hard measures of 1 through 9, and those I can set up in advance. But in terms of how the relationships develop 1 through 9, that I can only observe as my program goes on. And by the way, that's good to know, but I don't want to assume that that is the path that I need the next time I implement my program. And as I said, a lot of people would look at that last scenario and say, well, that kind of makes sense. But what I hope common sense. But what I hope I've convinced you is that between attractors and sense of dependence, there are actually good complexity-based reasons for doing it. So now it's time for me to shut up and open this up for questions.
Rob is raising his hand.
We had a little discussion in the chat about your first point regarding stable attractors, that 5 years would be enough. And we basically concluded probably not for many of the natural processes that we want to include in thinking about climate change, about ecosystem services, about sustainable development in general. And we see the stability as way further off than 5 years in many cases.
Sure.
So maybe you would want to react to that.
Sure. The first thing I'd say is I'm not a domain expert here, and I had to make something up, so I made up 5 years. But as you know, that's a strictly, I did that for, as they say, illustrative purposes only. I have no problem believing that the real time frame is different. And I don't know, Tim, if you've gotten a chance to read Rhodes's book on energy, but if you really want a sense of how long these kinds of transitions read, is it Richard Rhodes? I forget his name, but it's basically the history of energy transformation from the time when England used only wood up through today's renewable and nuclear power. It goes through all of the transitions and what happened and when and how long it takes. You read that, Rob, you will absolutely know that 5 years is a ridiculously small number of years. It's a great book, by the way.
Great.
You're absolutely right, I'm sure.
Johnny, one of the questions that Kate Wolfenden chatted in was if you could just really briefly mention the 4 other behaviors that are in your paper, because I think that those some of those might be particularly relevant to some of the thinking on signals of transformational change.
Sure. Why don't you flip back to that slide? Stigmergy is a concept that was originally developed, I think, by an entomologist doing research on some kinds of insects. But the idea is this: imagine you have a bunch of independent actors, but each of which has free choice, whether it's an ant going to looking for food, or somebody building a building, or a research team developing a research agenda, whatever it might be. But imagine that these entities are not coordinating with each other in any central way, that each one does something such that when the entity comes in behind it, it looks around and its choices have changed. And because its choices have changed, so it changes your range of choices. One research group begins to publish on a particular subject. The second research group comes along and says, how are we going to develop our research? We can do anything we want, but given what these folks have found out, maybe we ought to do this instead of that, right? So the idea is that independent agents, I don't want to use agents because that's a technical term, independent entities do things which affect the free choice of the entities behind them that come after them. And so you can imagine how, if this is the case, something will look as if it is highly centrally coordinated, but in fact it is not. And that's this notion of stigmergy, and I believe it came out of insect behavior, because if you think about beehives, for instance, that kind of emergent behavior, which I'll talk about in a bit, you'd say, my God, somebody certainly must have, that queen bee must have been awfully busy, laying out the plan. The fact of the matter is that each bee makes an independent choice, but the bee that came before it has done something that changes the range of the choices that bee can now make, or that research group can now make, or that set of urban planners can now make, or whatever it might be. So stigmergy is a situation where you change the choice set of what comes behind you, which then makes something look as if it's highly coordinated in some central fashion. Emergence basically means that, well, let me tell you what it doesn't mean. Everybody, how much time do I have?
Actually, I think if you could go through these pretty quick, so we've got some time for discussion, that'd be great.
I'll go through them pretty quickly. Think about a cylinder in an automobile, right? Everybody knows that a car is greater than some of its parts, right? But if I'm riding in a car and you said to me, what is that cylinder? I can say that cylinder is operating and here's what it's doing. The identity of the cylinder is still what it is, right? If on the other hand, you think about the vitality of urban life or a traffic jam or a beehive, those parts combine in such a way that you cannot explain the phenomenon in terms of the individual identity of each of its pieces. That's emergence. A phase transition means a relatively sudden change from one set of conditions to another. Now, the classic in physics is, a liquid to a gas, that kind of thing. But it happens in social life as well. Right? You look around and say, my God, we never used to be that way. Now we are like this. Self-organization basically means the ability of a system to gravitate back to its original condition when it has been perturbed without control, without direction from the outside. So in that sense, it's very attractor-like. But if you think about, what's happening now with the pandemic, right? Everyone says, oh, things are it'll never be the same. Well, I don't know if that's true or not. It could be that between the therapeutics and the vaccine, the problem goes away. And we had a system. It had to do with urban life. It had to do with people being in offices. It had to do with relationships amongst people. And I can easily imagine how things are just going to evolve back to the way they were, because there was good reason for it to be the way it was. Right? So that's this notion of self-organization. No one's, quote, telling the system, unquote, what to do. But if you leave it alone, it will somehow internally make the changes. I got to be careful because I don't want to anthropomorphize here, but it will organize itself back to its original state. Now, it might be perturbed from the outside. It's not isolated from the outside world. But once that perturbation goes away and you leave it alone, it evolves back to its original state. So
thanks, Johnny.
A lot in 5 minutes, but 5 minutes, that's the best you're going to get from me.
I will just reference that there's a nice laying out of these 6 different complex system behaviors in the paper that Johnny wrote that's linked to in the calendar invite and some of the emails. And we can definitely share that again if people are interested. Thank you again, Johnny.
My pleasure. People have questions, that's great. If not, you're all nice people anyway. It's fine. Okay, I have a couple of thoughts about that. One is, it's not as if we know nothing, right? And so, and I didn't put this in there because I wanted to make a point, but obviously if you have good empirical data or even good theoretical data to believe that A is connected to B and B is simultaneously connected to D and E, and you have some data or a good reason to believe that, you're not going to ignore it. At least I don't think you should ignore it. So that's one thought. Is that if you know it's one thing to say, and I didn't get into this previously, but when you see these big complicated models, what I have a picture on this, I'm not going to show it, I believe is they can be correct locally, but not globally. So if I said, look, here's this model, and I've got 20 different elements and X number or however many different connections, it may be that you can zero in on this thing and say, this small part of the model is something I can trust. But as you go further and further out in the model, it gets more and more elaborate. That's when you get to this situation where sensitive dependence in some part of the model is going to ripple through the whole system. So I would say if you really think there are relationships, you ought to look at them. That's the first point. In fact, you're obligated to look at them. The second point is, I think, is that I've never understood why people pick a model and evaluate to that model. Because it seems to me you can have multiple models that you can evaluate to. Now, you can't do that if one model and another model require an entire different data set, and it's just a lot of time and money. But assuming it's mostly the same data and it's an analysis question, who says you only need one model? But beyond that, I think the trick is this. I think that some of these complexity concepts, planners and funders are okay with, and some they aren't. So like this idea of stigmergy, the idea that you can have independent action that affects what other following entities are going to do, that's pretty comfortable from a planning point of view. I don't think you would have trouble getting people to believe that. On the other hand, if you said to them, I can't really tell you in any reliable fashion what the intermediate outcomes are going to be, that's pretty uncomfortable if you're spending public money. But a sensitive dependence view would say that that's true. And so to the extent you can get people to believe this stuff, that's great. But who's to say that you can't evaluate with respect to complexity, even if you're also evaluating with respect to non-complexity, right? So let's say you've got some model that has sort of an elaborate set of relationships. You can analyze that data if you wanted to, but you could also say, look, there's an emergent effect so that as these things interact, there is a sort of a causal element here that can only be understood by putting all this stuff conceptually together. And that's an analysis issue too. So, you know, you can sort of cheat in a way, right? You can say, yeah, you want me to evaluate relative to this complicated model, and that's what I'm going to do. But by the way, I've got this other analysis as well. You might want to take a look at it. So sometimes you don't need to have your funders and planners develop their plans based on a complexity view of the world. Now, I think they should, and I can argue that they'd be much better off if they did. But from an evaluation point of view, I can see ways of having it all. And again, I don't know if that answers the question, but for the moment, that's my answer.
How do you know that you're actually heading toward a new attractor state
Right.
from a practitioner or evaluator standpoint?
I guess I'd say a couple of things about that. One is, I don't want to imply that in the field of transformation, people aren't thinking about that. Sort of towards the end of my paper, I actually give examples of at least a couple of different examples I found where people are talking about networks and clouds of effects. And I think I used to have 3 examples, but Rob made me take one out because I was pushing my word limit. But there are some examples in there. So it's not as if this issue of networking and uncertain effects and uncertain paths through systems are not being recognized. Really what I'm arguing for is a continuation of that intellectual tradition that's going on. That's the first thing that I would say. The second thing that I would say is I think you are right about this issue of state changes or phase transitions or whatever you might want to think about, which is, how do you know what the intermediate stages are? And I would say, I'll give you optimistic and pessimistic answer. The pessimistic answer is that you can't tell, you can't know. And, you know, think about the Republican Party in the US. If I predicted 10 years ago that the Republican Party within the space of a couple of years would look the way it looks now, you would ship me off to the loony bin. I'd say, that can't be. Or if I said to you before 9/11 that there will be this new federal Department of Homeland Security and the United States Coast Guard will no longer be within the Department of Transportation, but would be within this sort of entire new government department with a cabinet position, you look at me and say, that's crazy. And what are you talking about? That can't happen. So the problem is that if you really believe in these kinds of phase transitions, you can't predict it. You know, if it's a physical system, you can. Give me, you know, pressure and temperature. I'll tell you when a liquid will turn to steam. But in terms of these kinds of social situations, I don't think you can predict it. But it doesn't mean that you don't have good reason to think that you're making progress. And that makes sense to me. You know, take this example of, you know, if you knew that changes in taxation regulations affected people's purchases of renewable energy. That's a good thing. Nobody would say that's a bad thing. Everybody would say that's something that, you found some way of getting people to choose more renewable energy. Whatever this new attractor is going to look like, people are going to choose new renewable energy. And I don't know the tipping point at which it'll become the new normal, but I know you got to move off in that direction somewhere. So I think those are reasonable things to say. I think the problem is if a funder came to you and said, I really want to know how far I am from this change actually becoming manifest in the world. I would say that's impossible. On the other hand, look at all these beneficial changes and everybody would agree that these things are important. So that's how I would look at it. Well, let me throw something in here. Anna has said, have you found examples that effectively take these into account? The answer is no. I have to say, when I talk about this stuff, I sometimes feel a little bit like King Lear screaming into the storm, with the storm screaming back at him. But I am actively looking for people who have been taking this stuff seriously and using it, who want to talk about how to use it seriously, because I see that as data in my case study research on what the applicability of complexity is to these kinds of programs. So if anybody is either doing it and wants to talk about it or thinking about doing it and wants to talk about it, you all know where to find me.